Hello, the lesson that is developed in this video corresponds to the first part of the module dedicated to glass fiber reinforced cement that is commonly known as GRC. In detail, this lesson will be dedicated to the description of the materials and to the manufacturing methods available. GRC is a cementitious composite material that is the result of the merger of two common construction materials, cement mortar and glass fibers. This material was created nearly 50 years ago due to the prohibition of using asbestos fibers in the construction industry due to their harmful effect in human health. The option to substitute such fibers were glass fibers. As is probably well known by all the students of this course, cement mortar is composed by sand, cement, water, and in most cases some chemical additions. There are no regulations that establish the characteristics of the sand used, but in general practice, fine sand is the most used option. This type of sands creates smooth surfaces in the element manufacturing. Regarding the cement, there are no limitations in the election of the type of cement used. However, if the characteristic gray color of cement is not desired, it is recommended to use white cement. Drinkable water is up for GRC manufacturing. The additions used can be of various types depending on the property of the material that is desired to be modified. For instance, superplasticizers are commonly added to achieve the desired workability that is needed in the several types of manufacturing processes that can be performed. Another addition that is commonly used are color pigments. These additions change the appearance of the element manufactured, widening the number of applications of GRC. Regarding the top glass fibers, it is important to highlight that not all types of fibers are added in GRC manufacturing. Due to durability problems among all the types of glass fibers available in the market, only those that are termed AR are suitable for GRC manufacturing. The usual length of the fiber used are between 25 and 40 millimeters. By using the two materials previously cited, an standard composite materials is obtained. The remarkable properties of the cement when compressed are kept in GRC. In fact, there are hardly any difference between the compressive strength of cement mortar and the one of GRC. Moreover, the use of glass fibers provide to the cement mortar two main characteristics of the composite material: an improved tensile strength and another characteristic that is even more important, ductility. With the merger of these two materials, a composite material with great compressive strength, improved tensile and flexural stresses, and with ductility is obtained. But now the question is, how is it made? GRC manufacturing nowadays can be performed by any of the three processes that can be seen in the slide: by a premix process, by then pouring, by simultaneous spraying of cement mortar and glass fibers, or by premixing cement mortar and the glass fibers and afterwards spraying such materials into the mold. Several characteristics change among these three methods. First of all, the amount of fibers used. In the first and last method, the amount of fibers used is 3% of the total weight of GRC. However, in the second method, a 5% weight of glass fibers have been traditionally employed. Another point that should be highlighted is that the properties of the GRC obtained vary not only due to the changes in the amount of fibers added, but also due to the change in the length of the fibers used. While in the premix method and in the spray method, only one length of fibers are added, in the spray premix method, usually two different lengths are used. The first method that is going to be explained is the first method that was used in the early developments of the material. Premix manufacturing starts by weighting the components of the cement mortar. Traditionally, the proportions used have been 1 part of cement, 1 part of sand, and half part of water. All the components are added to the proper container when the mixing takes place. The components are mechanically mixed until the desired workability is reached. Once the cement mortar is ready, the glass fibers are gradually added to the mix while the mixing continues. After a certain period of time, an homogeneous distribution of the fibers is obtained, and the GRC is ready to be poured into the mold element. This process can be seen in the video in the next few seconds. Now, after the compaction process, the manufacturing of the element has ended. In the case of a spray GRC, the process is similar to the one previously described. In the video appear two different devices. The first one is the cement mortar mixer, the second one corresponds to the spraying machine. Similarly to the premix method, the cement, sand and water are added to the mixer. Once the desired workability is reached, the cement mortar is added to the container of the spraying machine. Glass fibers are incorporated by means of a glass fiber roving that is introduced in the cutting and spraying device. This gun cuts and sprays the glass fibers while at the same time is able to spray the cement mortar. The cement mortar and the fibers are projected into the mold, covering the entire surface. When the desired thickness of the element is reached, which is usually 10 millimeters, the surface is even manually, as will be seen in the video in the next few seconds. The last method that is going to be explained is the spray premix GRC manufacturing process. The process starts by weighting the cement mortar components as in the previous methods, mixing the cement mortar at high speed. This can be seen in the image in the video where the mixer is mechanically mixing both the sand, cement and the water and plasticizer that were poured in first place. Once all these materials are poured, the workability is adjusted using one plasticizer. Once this process is obtained, the most important thing is to increase the speed of the mixer and then to reduce it while pouring the glass fibers into the mix. It has to be reminded that in this type of GRC, two types of lengths of glass fibers are added, being 12 millimeters and 40 millimeters long. Once all the fibers have been poured, a thorough mix of all the components has to be performed until the desired workability is reached. The mix that has been used is poured into the container of the spraying machine, as can be seen in the image of the video. It has to be done slowly to avoid bags and components of fibers being together. The spraying process is repeated similarly as in the previous video of the other methods. It has to be highlighted that once the first layer of GRC has been poured, the shape of the mold has to be the GRC has to be adapted to the shape of the mold using an helical roller. Once this has been performed, a second process of spraying starts until the desired thickness is obtained. And this will be the three most important GRC manufacturing processes. All these videos has been modified from the sources taken from YouTube that can be seen in the slide, and we will continue talking about GRC in the next few lessons. Thank you for your attention.